All right, everyone. We're going to start today. We've got a presentation by Miro. Miro is from the STEMSEL Foundation. So education focus, microcontroller focus, it's very cool stuff. And STEMSEL is one of our sponsors for the hackathon. And so the information in this hackathon is going to teach you how to use the microcontrollers that will be provided to you in the hackathon for use and integration into your warships. So, Miro, present. Okay.
Sure. All right. I'm going to. Someone here has their laptop, so I'm not going to make it hands-on then. I was going to do part of it possibly hands-on, but I'll just show you from here. I've got lots of things here that I can show, and I'll be presenting obviously up there as well as to how the controller works. Okay, so a lot of you remember, got activated at the moment, but the controller I was shown last time, sensor. So we'll actually be going through that as well, and through the runlinc system, which is on the controller as well. Because take notes, but also we will be giving the resources out as well. So this will be recorded, but also I'll be sending out probably on email. That's the easiest to actually send out to everyone links to everything that I'll be showing today as well, just so that you can find it easily. Okay. All right. Go to the next slide. So the runlinc is the operating system which is on the microcontroller, and I think I mentioned last time that it is a web page inside the chip. So I'll be showing you how we can connect into that easily, because it is actually a Wi-Fi chip. So it connects by Wi-Fi. So that's why on a battery I can still access it on the computer. So that'll be an advantage for you as well, because you can have the controller obviously in one place, work on it, and you can still have the laptop over here as well. You don't have to have like wires, strands, and everything as well. And the sensors are connected there as well. I'll go through that carefully. All right. One of the features of runlinc, we'll go to the next slide, is that it is much easier because there is much less code that you have to put in there to get things working. And it is also coding that is well known, such as HTML and JavaScript as well. Okay, and you don't need to install anything to make it work because it is on a web page. So you don't need to put any drivers, you don't need USB drivers. You can just open the web page, make sure that the Wi-Fi link is connected into the same link as the chip, and then you can go straight to the page on the IP address. So it can work across the local network, and we can then put that local network as well onto the internet as well, but probably you won't be using that feature. Okay, go to the next one. I'm going to go quickly through these slides because I want to get onto the actual controller, so go through that most of the time. So there has been a research paper about the comparison between, for example, Arduino versus the runlinc, and that has been submitted for IEEE conference, and the conclusion was that the runlinc is more effective for the IoT STEM projects, even easy enough for even 9-year-olds to get started. But we have had lots of industrial projects working as well, and it has proved to be helpful even for adults to use it, particularly where the adults don't have even like a lot of experience in putting projects together, and in third world countries and all over the world for that. So go to the next section. Okay, so it only takes one line of code, for example, to connect the camera. So it's showing a phone camera, And so if the phone is connected to the same network, if you put the phone on the same Wi-Fi network, and then you make that your camera available on, say, an IP link, which you get an app for that, obviously permissions, then the runlinc can pick it up just with one line of code. Then you can stream across the network, you can get video onto the runlinc webpage. So runlinc can actually build your own webpage, and that is your panel, that is your display. Okay, the web page. So it only takes one line of code to put streaming video onto the web page. Okay, it takes 2 lines of code to put 2 buttons onto that web page so that you can turn things on and off or activate even subroutines and subsections as well. It's only one line of code for each button. Okay, next one. And 3 lines of code, you can add the AI voice. Okay, we showed the AI voice last time as well. In fact, let me see if I can activate that again. That's right. Okay, got a different message in here, I think, for someone overseas, but anyway, if I cover it. Right. Just take a look at the turn that on. All right, so obviously the voice is coming from my laptop, so it actually is activated onto the browser. Okay, so it's browser. I'll show you a bit more of that a bit later. Okay, got one. Okay, and we have had young ones use this system instead of being addicted to games. Okay. Right, just a few case studies as to where we've been using it just quickly. So we are partnering with DFAT in Australia, for example, for IoT fish farming in Nepal, where they also are doing STEM there as well. In Thailand, we have Prince of Songkla University, and they have even created a whole house IoT using the runlinc just as a case study, and they're also going to make that available across the internet so that people can actually see how the runlinc works across there as well in Thailand as part of that university. In USA, Dr. Victor Lawrence is in the Inventors Hall of Fame, and he's put us across STEM schools and other places over there as well. I did get to speak also to, I think was part of the United Nations for Women to get them to use in STEM, and we have a good supporter in there as well who's in Philadelphia. She's a lawyer there as well. And in Malaysia, in Penang, it's a similar problem to what we have here in Adelaide. So I know one of the priorities of DEXA is to get more STEM workers, because we need STEM workers in defence. So in Penang, they have a similar problem. When I went to Penang in May, they saw this system and they basically said, yeah, we really need this. And so lots of things are happening there as well. Dr. Chia is an inventor. He has 167 patents working for Intel over there in Penang. Penang is a sister city to Adelaide and also the defence, it's technology hub of Malaysia, just like Adelaide is of Australia. All right, that's about it really. So I'll do the demo. So if you can turn off the sharing on that one, I'm actually going to share the screen that I have here. Teams. going to share what I see on the screen for the web page for this device here. I'll step through it carefully. Share. That's the page because I didn't tell them. All right. Just going to reload this because I loaded firstly that code for the sensor just now. So this loads directly off the chip. So even if there's no internet, the local network will actually get that page. All right. How do we connect to that? Well, at the moment, the chip also has settings. See that line? Okay, good. So you notice that I was on control.html. So the IP number is the IP number of the chip, and they do have numbers on the top of them. So this one is 57. First three numbers there is of the hub that I'm using. It's this one here. I'm using that for a reason. Okay, because later I want to show you how it even connects to. Right, do that at the end. So I'm going to settings just so that you can take a look at the settings. So that's the board number, that's the network name, then it goes to the hub, and there is a password there as well. So that is the default settings anyway on the chip. Now, if you don't have that network, then after 10 seconds, it creates its own network. So it'll basically come up with its own Wi-Fi hub on the chip. And the Wi-Fi hub will just say runlinc 57 in this case, and then have a number after that, which is like a serial number, and that'll just come up on your Wi-Fi. Okay, so you don't actually have to create a hub. If you just leave the chip on for 10 seconds, it'll create its own Wi-Fi, and then you go obviously to your Wi-Fi settings. Okay, just open up. Oh, I'm not sharing that bit. Okay. Anyway, if you go to the Wi-Fi settings, you'll find it on the list. Right, I'm going to go back to the control page, control.html. And once we connect, usually we just check the connection. D2 is connected to a blue LED, which is on top of the ESP controller on the top here. The reason I put this on battery so I can show it up here like that. If I click on it, you can see it's got a blue LED thing. Okay, click on it again, it takes off. Right. So I'm going to show you a little bit of code here as well in the different sections. Let me load up sample. What I might do is just show you the coding. So let's say, so at the moment, all right, that's the blue LED. Now we want to also connect in other devices. I have here a white LED. You see that you can see there's a white LED here as well. So you might have actual LEDs on what you're building in the hackathon, okay, as indicators, or for other reasons. You might also need outputs for actuators and things like that as well. At the moment, this LED is connected, actually it's two LEDs, there's actually 3 pins on it. So if I make a digital out, this one here, I believe is the green one, and I can test it simply by clicking on that as well. That's red, okay, get to red then. Okay, not that that matters on the test. So in the status, you can actually test things in the status. Obviously, want to test things electrically before you then use it for the code. So the word red can now be used in the code. That's now a variable in the JavaScript. We use JavaScript because it is native to the browser, and so you don't need to load up anything else. So I have a red LED. We also have on here connected a sensor, which is on D33. Set that to analog in. Okay, that's the raw data coming off the sensor. It's a voltage. It produces a voltage. Then, if I cover the sensor, then you actually then also get a response on the sensor as well. So cover the sensor, you can see the lower limit and the upper limit on your sensor. So any voltage that's on there with the analog in can be converted to the sensor number. Okay, I'll go through some other types of sensors as well. Just want to go through an overview first on how this works. So if we type in sensor, if I then say wanted to check the sensor in the code, I can say if analog in, and then select the sensor. You can type these in, and macro. If it's then greater than, say, 320. Okay, and we can just turn on red LED. Anything else? This is a standard JavaScript, but obviously the variables red and sensor come off of here. And also analog in is obviously an extra function in the chip, which is listed on here. We have analog in, we have turn on, turn off. We have other devices on here as well. So else turn off sensor. Turn off the red LED. We press run. Okay, put my hand on the sensor. You see the LED turns on. Okay, take the hand off, it turns off. Right, so it's encoding. So that's how what the connection is with the variables that you set up there. So then the runlinc also, so we can, the JavaScript loop repeats, okay, it's a loop. The JavaScript here will initialize any variables, and also you can set up functions as well, but it won't obviously be running in a loop. So that's why we have two separate JavaScript sections in there. I don't know if many of you are familiar with JavaScript or HTML, but there is also a very good reference which you can use. Have many of you used like W3 schools? Yeah, getting lots of nods. That's good. All right. The code from W3 schools, the examples will run directly on this, so you can cut and paste it, and then it'll run inside. So in the HTML, go through quite a few things. In the HTML, for example, we can create the web page control panel. So you just putting a bit of text in there as well. H1 is a large heading. Okay. Typing this straight in just to show you that it is only a few lines of code and quite easy to understand. So I'm going to create two buttons, and when we click the button, we're going to turn on. Well, let's turn on a different LED. I actually have check there is port numbers on there. 19. So 18 should be the green one. Yeah, comes up green. Okay, and by the way, I have put that 3 pins of that dual color LED across the ports this way, but there are 3 pin connectors across here. The one that's closest to the controller is the actual port connection. The one in the middle is the positive, and the one on the outside is the negative. So, for example, on this sensor, okay, you can see the 3 pins possibly. Okay, there is a signal on one side and then positive, negative. Okay, so I can just put that in the ports. This is just like small pins also that you can use for like Miro board pins and sockets, so you can plug straight into there and you can use that for on the cables as well. Yeah, so that's how the sensors are connected. We do have some pictures also with the documents, which I'll show you soon. Right, just wanted to show you that. So on click, we're going to turn on the green LED. Okay, and at the top, we can put on create your own label. That's the end of the button. Just creating a simple button. Example web page to connect in. Obviously, the turn on green can also be a function that you put into your JavaScript. Any type. Just creating another off button. Right, just an example, an off button. So if I click the run code again, it'll include all of the code. So we have down here a preview of the control web page. So the web page, then if I click the green on, then it'll connect because I have it labeled up here as well. So it goes straight to the port, and you can see in the status it does turn on as well. Off, right? So they're active buttons on there as well. With the JavaScript, you can send data from the sensors into the HTML page. You can put that on there. So you can display the data numbers. You can also put that into a graph or any other way you want to display that too. Question?
How would you check the status of the line?
Sorry, check.
If you were to say 2 bucks at 1 toggle on off, how would you check that it's already on so you could run that toggle on?
Well, then you would probably write some JavaScript so that you can actually check the pin.
Would it allow for you?
I can't remember what the function is, but there is a function where you can actually check the port. Okay, and I'll make a note of that and send that to everyone as well. Yeah, if you need to check the port.
I have a quick question.
Yeah.
See that drop down button on the JavaScript, the first one, so where it says turn on, you just click on that. So that has a drop down of all the.
Yeah, you do
Oh, that
you
one?
can see before because you're on a sharing window.
Oh,
Yeah, so if you go back to Teams, just share.
okay. Let me just share the whole window.
Yeah.
Because if you didn't see that.
Please go back to Teams. Yeah.
Yeah. So it's shared.
Start again.
All right, share that.
Okay.
All right, go back to it. Okay, so when I click on this one, yeah, you can see it now. Sorry, I didn't realize you can't see it. All right. Okay. So yeah, when you click on it, you can get a whole list of the functions that turn on, turn off, and log in. Yeah, and there are other functions in there as well. The DS18X20, you might be familiar with that. That's a precision temperature sensor. We have like TTY serial lines going in and out as well, so we can actually send text to other devices as well.
So if I wanted to use I2C or SPI or anything like that, how would I implement that?
We don't have an I2C connection on there at the moment. But we are actually working on I2C at the moment, so it's not very far away. So hopefully we'll give you some chips which do have I2C on them, so that's an option for other sensors you might want to use.
So you're essentially basically writing code and then you have a parser on the chip.
Yeah.
Passes the.
Yeah, across the network, that's across Wi-Fi, remember. Yeah, well, to keep it simple and quick, yeah, because of the access and then getting the web page as well, being able to develop the web page quickly. Yeah. All right. Any other questions at this stage? No. All right. Okay. The next thing I was going to show is, I think I'll show you the servo motor. I'm going to connect a servo motor because I believe that what you're building is going to need a servo motor and even a DC motor. I'll show you in a minute as well. So the controller actually has pins on it as well. It has sockets and it has 6 pin connectors here as well, 3 pin connectors which connect directly into servo motors. Now, the power pins on the servo motors are different from the power pins on the sensors and the other ports. Okay, the power pins on the servo motors go directly from the V-in power line, which means if it's connected to 6 volts or 5 volts, then it'll get 6 volts and 5 volts on here, whereas the chip runs on 3.3 volts and it's regulated to 3.3 volts. While I'm talking about power, we also do have a 12 volt connector here as well. So if you want to run your system on 12 volts, then there is a regulator under here which will convert it back down. The V in then will become 5 volts and the chip will still run on 3.3 volts and you have access to those. The reason that we got a separate power line is because then it doesn't need to go through regulators to run the servo. So you can have a really big servo. Okay. The lines on here are like 1 millimeter wide, so you can have a lot of current, you can have a large servo motor in there. Okay, I'll plug it in. It's got six connectors in there, so you can have 6 servos connected directly. But the other ports also do run servo signals. I'll show you how that works. Okay, I'll plug it into port 14. I do have an example. 14. Right. There is a load and a save, so you can save your projects. By the way, actually, before I do the survey, I was going to show you another thing on the runlinc. You can save your projects. Okay, so if you typed in one or hopefully a better name than that for your project, a descriptive name. If you press save, it'll actually do a download to your downloads because remember it is a web page. And then if you do a load, you'll need to go back to the downloads. And then the demo one will be there and you can click on it and open. Okay. So, but you can pick where it downloads anyway. All right. Now there is also board, get and send. So I'm going to send this project to the board. So that means that this project is then sent back to the chip and the chip will store this project. And also it sends 2 files. It sends the project file with all the configuration and all of the code, but also generates the index file for the web page that you've just generated as well. And so you can access that web page separately as a control panel. So if I then go up and delete the control.html and just go straight to the chip, then it'll go to the page which we've just made in there. So if I press green on that one, then the antenna is green. Okay, if I cover the sensor, it actually goes yellow. Why does it go yellow? Huh? Oh, she can get it.
Got ready going on,
Yes.
it's hard.
Remember that when I covered the sensor, it went to the red LED. So there is green LED and a red LED there. It's not RGB. What is red and green together? Yellow with light. Okay. So anyway, so that's how you access the page. I'll just go back again. Page. I'll show you the servo motor. Just cancel that. All right, by the way, if this happens, by power outage your device, okay, so it's completely unpowered, then obviously you can't access the device. But if you power it on again, then it will reconnect to your page as well. So you get the digital out again and turn it on. Okay. All right. I have the negative of the LEDs connected to D19. So if that port is off, then it's actually negative. So you should actually set that as well, because the connectors are across the signal pins. All right, let me show you the servo motors. Let's get to that. This takes too long. I'll go back to my example into my downloads. I do have a servo buttons example. Okay, so in this case, the servo motor, which is connected to D14, can also be tested. Okay, so it's not put on at the moment. Set that red one. Right. So if I click on the bar here, okay, you can see the servo motor moving. Okay, so you can actually test that as well. And then I'll run the code. In the code, you'll see that it actually just has function set servo, goes to servo 1, and then it has the angle there 0, 90, 180. So I run the code, the example, and press the 0, goes back to 0, press the 90, goes across to the 90, etc. 80, back to 0. Okay, and similarly, have the sensor one here as well. We open that one, so that if I cover the sensor, it says greater than 80. That's not a good idea because my sensor's already at 180. It's darker than that. This sensor goes up when you cover it. Set that to 200. And you can see that it's a lot quicker then also to see where your sensors are at as well. Okay, otherwise you're coding blind. So that did jump over at 200, so I'll just make it 220. Run the code. sensor. Okay, so if you can watch my servo motor when I cover it, goes across. Okay, try and cover it back. Showing you a few simple examples. To reload the page. I want to show you a DC motor as well. Forward, reverse. We want to forward and reverse, and we also want speed control on it, basically. Right. We do have screw terminals on the front. Now, under this chip, I do have a driver as well, because obviously the motor is not going to run off the chip. It's too much current to run directly through the chip. So there is a driver chip under there as well. Okay, and there are 4 ports here which are labeled D for driver. So there is a D13, D12, D27, and D33. Okay, those same numbers are repeated over here. So for example, the sensor is on 33, but that's an input. And that input can be an output as well. It depends on the configuration. And that goes to the driver and to the D ports here. So you cannot put a light sensor on here because that's connected actually to the driver, D for driver. All right. I'm going to use the screw terminals and connect in D12 and D27. Motor on there. Seven. So take note, because I think you're probably going to need a screwdriver in your team as well to do some wiring, as well as maybe some wires to plug in as extensions for your sensors and things as well. Right. And by the way, I'm powering it using the connector which is on the chip here, but there is also a voltage entry as well, so you can wire in battery whatever in there as well directly. And like I said, it can be a 12-volt battery. It is a regulator though, so that 12 volts could be 9 volts if you wanted to. It just goes through a regulator back down to the 5-volt rail. Right, it can go up to 15 volts actually. All right, so I've connected the motor. I had that unplugged, I think, while it was loading. Okay. All right, so I have it on D12. On D27, did I say? Okay, so that would be motor forward. If I click on that to test it, motor goes forward. And turn it off. The other one should be reverse. Be hard to tell whether it's going the other way. Because it has drivers in both directions. The drivers work negative forward and reverse. Okay, for speed, we do have PWM on our ports, which is accessible also on the code. So if I click that on PWM, then we can have it quite fast forward. I can make it slower. Of course, with modulation, and slower. It's slower, will eventually stop. Okay, it's only so much, less than a certain amount of power, it'll just stop anyway. And obviously won't start at that power either, so it needs to go back up there to get it started. Okay, so how do we code that? I have an example. Okay, motor speed. You'll notice that when you save and load, it also saves the import settings and everything as well. Now I have here is greater than 30. Cluster testing is a different sensor. So change that to 220 again. And this just changes the setting on the pin. So the set pin is a general setting on the pin. Okay, you can change the settings on the pin. You can even use that on the servo setting here. You can see there's a servo output. You can use the set pin or you can use the set servo. So, okay, run the code. Cover the sensor. Okay, goes high speed, and then if I cover it, I think it goes lower speed, still going. And you can see the speed on there as well. If I cover it. Okay, we're on cover it.
Jawaba may discuss whatever.
Okay, so is there any questions on the motors?
The motor drivers ready to.
Sorry?
What current motor drivers?
Good question. It's only the little L2293, which only goes up to 600 milliamps, and you don't want to push it okay for a long time either. It will heat up. It does have the pin soldered onto board with a large patch on there with a little bit of dissipation on there, but you don't want to keep it heated too much. Obviously, it's enough for small motors. It's enough for relays as well. So, for example, there's a little relay in here. So it'll trip relays easily. If you need more current, you can do that. And if you use solid state relays, then you can use the PWM relays as well. Okay. All right. Any other questions for that? I actually need to pop into the toilet quickly, so give me a minute just to break for that. pretty much how much memory there is. So there's actually quite a bit, especially if it's just simple text like this. All right. Any other questions have come up meantime? Any other questions in the meantime come up? No? Okay, I'll go on to the next thing I was going to show. And that is actually, I do have one here. I do have another chip here on the table. I'll just show you quickly. Also, I was going to show you the relay. I do have a relay connected to the 13. So the lamp here is connected on the table. Okay, yeah, the relay connects, just plugged in the main, so plugged in the main, so turn that on and off as well. So you can put relays on there too. Right, it's not, yeah, just a LED lamp. All right. I want to show you where the resources are first, and then up to one of things. Okay, this is runlinc.com. Runlinc.com. And the documents, we've got runlinc projects. There are small projects in here. There's a setup guide, which goes through Wi-Fi connections, etc. It also goes through how to make the IP address onto the internet, if you want to do that. And then there are projects in different levels. Very simple projects about connecting alarms, smart lights, etc. Examples, so you can go through those. Intermediate projects as to, for example, how to set this one here was probably interesting. I'll open this one, the wind power, because it shows a few things that you can also put onto your web page, the runlinc web page. By the way, this one uses the motor in reverse. When you blow into the motor, it actually measures the voltage generated on the motor, picks it up in the chip, and then displays it onto the page. Page, no. Yeah. Anyway, with this one, it actually has sliders on the page, as well as the numbers come up on there as well. So you can see the documents show you connectors. You can see the connectors going across the ports there compared to, and also using the wiring, you can see just using the pin connectors on there too. All right, and there are diagrams as to which one's negative, positive, and the signals on the inside there as well on the board. All right. I also want to show you that we also have a runlinc online. So go back to the home page on runlinc.com. If I go into users, then you can create your own account, press register, and you can sign up for free. And you register and create your own user account because you can also keep projects on here as well. So we do give you a folder for that. I'll show you what that looks like. So we're not going to leave you with any controllers between now and the hackathon, but you can actually practice on runlinc with the runlinc online. Okay, definitely. And with the runlinc online, you can put in a project. You can press upload, and it'll actually upload into a list of files. So here, if I open files, we have a list of the files that I've uploaded, such as the alarm voice demo, and I can then edit that as well. So it goes back in to the web page for editing, or Please reopen the web page. Or if I just press it, then it'll actually show you the page running as well. And by the way, if then I shared this URL, then other people can also open the page obviously as well because it's on a running server. Okay. If you use the method, just as a by the way, if you use the method of connecting across the internet your board, then you can put the internet connection to your board into here. And you can open up then the ports on your chip, okay, even across the internet. Okay, and then you can create a project on here. When you do the upload, put it onto your page. If your chip is connected and it will go back to your chip, then you can share it internationally as well as an IoT device, international connection as well. Okay, not that you might use that on the hackathon, but you can do that as well. All right, one of the things I did want to show you, which I'll open on there though, is dates. One. There is a fetch satellite for data. In data, okay, so this example here, I should really actually open that editor. Okay, so what this example is for this device here. So I haven't shown you the runlinc connection part here, but if you take a chip, you put in 3 wires, negative and a transmit and a receive for serial data, then you can actually communicate with the transceiver for Mariota satellites as well. So you can send IoT data packets to that, and then once they're picked up, you can send them down into the runlinc online. So the runlinc online will actually pick it up and you put in your own user account. My user account is Miro2. You generate your own user account. It will be sent into your account and then you can pick up the data. So if I run code, and these couple of packets of data have been sent across the satellite, then the data is in hexadecimal like this, which you can encode. Okay, so that it can be used in remote locations as well. We're still to discuss as to whether that's going to be available in the hackathon or not, but possibly if it looks like it might be useful, then we might talk to Mariota about sponsoring this device here. It's available for you as well. Okay, and I suppose the hackathon is competitive, so anything that you can put on there will probably add more points to what you've put together, I guess. All right. So that's the, I've shown you the online so you can see the receiving. I'll also show you the transmitting part of that as well. Get the file for that. So, transmit. Have a transmit sensor. This will give you some idea of how much code. You can see it's not an awful lot of code. Okay, what have I done? I'm taking the light sensor and actually then wanting to transmit it. The actual, right, show it to you first, code. So we have the title, we have the check state of transmitter. The message transmitted is this, okay, across, obviously I haven't wired it in at the moment. And then it will give a reply saying, and it'll give you the state, whether it's ready, etc. You check the free bytes using another AT command, and it'll tell you how many bytes are free. When you send the data, it goes into a queue. Okay, so it'll stay there in the queue until the satellite goes past, because it's a low orbit satellite, which is not available obviously all the time. So that could be 15 minutes, or it could be, sorry, 15 minutes apart, or it could be 4 hours apart for the satellites. Mariota, I believe, they did have 12 satellites. They might have more satellites up there as well.
Could you download an ephemeris to work out when that would be?
Yes, they do provide that. In fact, if you go to the Mariota site, which I think I've bookmarked, show you that question. Okay, so if you get one of these devices, it actually comes with a device ID that you can get from the serial port. In fact, you can get the device ID even using the runlinc, using an AT command. And then you can create an account, sign into my account, and show you, and then you can create destination. So when the satellite comes, then obviously goes to Mariota first, and then from Mariota you'll be directed to where you want it to go. And the destination I've just showed you is this Miro 2. Edit that, then this is it sends a HTTP request to the runlinc server. Okay, and then it tells it that the user is Miro 2. Okay, so when the satellite does pick it up, when it eventually finds a point on the internet, it sends it through Mariota's server to the runlinc server. Okay, I'll send you obviously information on that as well. I'm running through everything quite quickly today, but I will send you the links to these things as well. Right. Any more questions about the Mariota satellites?
What band is it operate on?
To the satellite, I'm not sure. I'd have to look it up again. And there is quite a lot of information. Mariota. And they're here at Log 14 as well, by the way. There's a Log 14 company. And yeah, it's a startup here in Adelaide. So yeah, it goes through all of that. There is a lot of resources on here as well. And then you can go to the developers section as well. Goes through the module in the kit and everything as well. If you go through their usual development system, it is actually quite tedious, where you have to set up the Linux and things. But using the runlinc that I've just showed you, obviously it's much faster. Otherwise, you wouldn't be able to even develop that on that hackathon. Okay. All right. All right. So the other thing I was going to show you is a little bit more about connecting across the Wi-Fi. So remember, I said that one line of code we can connect to devices such as the phone. I'm going to show you an example. Close the runlinc online. The runlinc online, we focus on the other controllers. All right, I do have the controller still running, which connects to the LAN, and I'm going to load some code, and I'm going to load some code as a project example for this Wi-Fi device. This is a Wi-Fi drone. Okay, it does have an IP camera on front. It also has sensors which are also accessible across Wi-Fi, like a infrared home sensor here as well. It uses a camera for its own stability. so that it doesn't drift sideways. The distance sensor for a distance sensor is so that it doesn't drift up and down as well. Okay, and it does take Wi-Fi commands as well. All right, so you just go and get that example on downloads. Okay, I've got some code for the local connection, which this is, and also have some code for an international connection. So believe it or not, I actually ask people overseas to open the runlinc web page and then control the drone from there. Okay, as a demo, right? Just to show the runlinc can work across the internet. All right, so I need to turn on my drone battery in there, which I believe is charged really well. Okay, I've turned on my drone. I then need to connect the drone to my network. Yep, it creates its own hotspot. So when I connect to the drone, it's actually on a UDP Wi-Fi connection. Does anyone know what happens to your Wi-Fi when you connect to a UDP? Blocks off everything else. So when I connect on that one, I do have a wired connection still into the internet as well, because I'm sharing. Right, otherwise my share will turn off. So I couldn't reach the runlinc chip either. Okay, and I'm using actually a small Python server to connect into the UDP connection, because you can't connect into UDP JavaScript directly. Security measure. Anyway, bypassing that. Go back to the screen. Okay. So run the code, take a look at the camera. Hopefully it's still connected. Right. Still connected. It's not okay. Unfortunately, Windows doesn't like devices that don't have internet. Let's try this one's internet. So let's try to connect this again. Okay. That one. Yep, camera view, so you can wave from that side of the table. Right, press the commands. Actually, there is a voice on here as well, but I believe it's going to echo if I try it. It's not good. All right. So we can check the battery percentage from the drone. That's the sensor, 76%. Going to actually give it a takeoff command. Give me enough lighting. Or if you fail, right? Give it a height from what you would want to see as 577 centimeters. Or 50 outside. But that's a 91 centimeters. This is around on the base. It's a hard one. Okay, we're going to fan when it's long, and it's towards rain. And we go flying. It's raining from land. Long, right? I'm going to say you might take the forward. Okay, and then to land. Okay, now there is actually coding here. Might be able to see in the JavaScript loop that says that if they activate the sensor and it's greater than 80, check what that is. Okay, I need 40, that's all right. Then it will send the drone up automatically. Say alert intruder detected sending security drone. So I'm going to use my hand on the sensor. Go up automatically. Go up a little bit higher and go around and take a video. Intruder. If I take my hand in the way, let the way the intruder, it'll range automatically as well. The code, then if it's less, and so project example. So you can see that there's just JavaScript functions drone. Literally, this drone actually takes text commands. So it's an AI drone. You can just text it, take off up 50 centimeters, counterclockwise 360 degrees, and that's it. So that's an example project, and also shows you also the camera view as well, which is still active at the moment. So but you can see the okay. And I'll turn off the drone, otherwise it'll turn itself off after about 2 minutes because it actually overheats without air. Heat sink under there, and after 2 minutes, it's like got 14 microcontrollers in there apparently, and they just overheat. There's no windows. So, all right. So there's my final example. So so now it's a time for questions. Questions.
Not just for Miro, if you have any questions for us, that's it.
Any questions?
These project files, will they be available to us to leverage during the hackathon?
Yes, everything I've shown you, yeah, those project files, you can have a look at those examples, definitely. And even on the runlinc online, for example, you go down, there are actually online projects as well. So these don't need a controller. So this is actually the IoT camera streaming, one line of code, which literally can use a camera, the online runlinc, 2 lines, buttons. The buttons don't turn on the controller, they actually just change a picture of the controller with the light turning on and off. We have IoT traffic lights, we have an AI voice storytelling app. We have object recognition. So on the runlinc, it only takes 35 lines of code to actually pull in an object library, take the camera, put it up on the web page, and actually do object recognition on there as well, with text coming up under it as to what the object is, with a number there, which gives 0 to 1. Percentage of confidence, that's what it's called, confidence. So there's confidence level as well there as well, and some have taken that text and turned it into voice, etc. as well. Okay, there are buttons there for the voice, the AI voice, and there is also AI voice recognition. Okay, which I don't know how useful that is in a noisy environment, possibly, but it will actually take the voice and turn it into text, which can then go into commands as well. So all 7 of those are available right now, and I suggest that you take a look at that. Easy to find because it's just runlinc.com, and then online projects here as a resource 7 free online projects get started. Okay. Any other questions? One triggers other things too.
I do have a question.
Yeah.
I'm a little bit confused about how you operate that. Chrome, so you're running a web server on your computer.
Right. Okay. This is a UDP connection. You can't access.
So you're running a web server on your computer.
I'm running a web server so that it can pass between the JavaScript and the drone. The drone does have Wi-Fi commands that you can pass through it, but only through a UDP connection. So obviously the laptop has access to that, and Python has access to that. So I just wrote a Python server, which then takes it and passes it one way and passes it the other. Okay, any other questions?
It's like the craziest project you've done. You've done with the most capability.
Well, the drone project was pretty high.
I've got one.
Question.
Yeah, do you know if runlinc will ever have like a desktop version for it at any point?
Desktop version.
Yeah, because I know you can do it with your laptop, but do you know if you'll ever have the ability to do it through your desktop as well?
Oh, works just as well on a desktop. You just need to make sure your desktop can connect to the Wi-Fi.
Ah, okay.
I mean, even if your desktop doesn't have Wi-Fi, maybe it's connected through a cable or something to your Wi-Fi system, then you can connect to it.
All right.
Connect on your phone even, okay? You can connect on Mac, you can connect on Chromebook, okay, which is hard to connect to usually, because it's just a browser. So if you just open the browser then connects to the Wi-Fi network, then it's got access to the chip. Does that help answer the question?
Yeah.
Okay,
Yeah. Thank you for that.
right. Any other questions?
Any particular browsers that are, I guess, work best with it, or is it sort of anything?
We usually prefer Chrome because it has lots of resources in there, but we have lately found that the big what do you call it? Edge browser is just as capable these days anyway. It works on Firefox. The hardest browser with most difficulties is the probably the browser on the iPhone, the Safari browser, particularly on the iPhone itself, because of the security blockages and things like that. Right, and Safari also has different JavaScript. Some of it as well seems to have its own language on part of it too. But if you do keep that in mind, then yeah, you can open that in. Any other questions?
Everyone, please give Miro a big round of applause. Presentation, and I'm sure we can all see how this could be very relevant and useful during the hackathon. You can sort of just imagine like a custom interface, custom website. It can get very exciting very quick. So yeah, really cool tech, and we're very excited and grateful to be able to integrate that into our hackathon. Yeah.
Thank you. All right.